A difficult topic for students is often the idea of elasticity varying along a straight line demand curve. On the board we have the simplest kind of demand curve, a line of -1 gradient where a price fall of £1 results in a quantity increase of 1 unit. This is a straight line along its entire length. At a price of 10, consumption is 1, at a price of 9, consumption 2, and so on. However, elasticity is not constant along this line. If we begin at the top of this demand curve with a price of 10 and quantity demanded 1 unit, a reduction in price of £1 leads, of course, to an increase in quantity of 1, giving us final quantity consumed 2. The total revenue, which is price times quantity, goes from £10, 1 unit at £10, to 18, 2 units, both sold at a price of 9. Total revenue, therefore, has increased. And we say that the marginal revenue, which is the change in the total revenue when we sell 1 unit, is 8. A price cut from 9 to 8 leads once again in an increase of consumption of 1 unit, and total revenue is now 24, which is an increase of £6 from 18, and so on. Total revenue ceases to increase in the middle of the demand curve when a price cut from 6 to 5 leads in no change in total revenue constant at 30. Further price cuts, again, see an increase in consumption, but this time revenue falls. We can, of course, plot this marginal revenue, and you will find that its gradient is -2. At this point on a demand curve, elasticity is said to be elastic because a price cut leads to an increase in total revenue. Using the formula for price elasticity of demand, percentage change in quantity over percentage change in price, we might see that a price cut of 10% leads to a quantity increase of 100%. And this is indeed elastic. We must be careful, however, as we will see, of relying on the formula. Always, a price cut which leads to an increase in total revenue means that demand must be price elastic. In the centre of the demand curve, a price cut has resulted in no change in total expenditure. Total expenditure and total revenue, the same in this case, P times Q. But if we use the formula, a percentage change in quantity compared to the percentage change in price which caused it, the price cut here is 1/6, which is 16%. And this has caused a quantity increase of 20%. This would give us an elasticity value which we would normally regard as elastic. However, if expenditure does not change with a price cut or a price rise, we say elasticity is unit. If we cut the price from 4 to 3 and demand increases from 7 to 8, here we see that a price cut causes total expenditure to fall, and this must be inelastic. Thus, demand curves which are often seen as elastic because they are flat are not elastic because they are flat. They are elastic because we are on the top part of a demand curve when a price cut would lead to an increase in total expenditure.